Hello and welcome to your Unit 0 video that is going to review basic math, the dimensional analysis, and then also identifying the different parts of the scientific method when you're given a reading passage. So I'm going to be doing this extremely old school, which is I'm going to be writing stuff out, and I will make sure that I refer to the specific problems that I'm doing. I'm also going to give you some tips and tricks along the way. There are some math problems that I'm going to be debuting to you a little bit later. I really want to focus on the stuff that I expect for you to know now. So this is going to go in three parts. The first part is that I'm going to be going over these math problems one by one. These were dimensional analysis stations that we ended up not doing because it was clear that I needed to give you guys a little bit more direct instruction. Then there are also, excuse me for a second, there are also extra dimensional analysis problems I'm going to go over. And then lastly, this is page 7 of your Unit 0 packet. I'm going to go through each one of these examples. So the only thing you're going to need is a piece of paper, something to write with, and your calculator. This is the one that I happen to use. This particular brand is not expensive. Usually you can get them on sale for about $10. The usual superstores have them probably for less money than the specialty office supply stores. You may be able to find them on some popular online vendors where you can get them inexpensively. I do have some that if you are in a pinch and you really need to borrow one permanently, whether you're in school or at home, please let me know. There are more advanced calculators you can use, including graphing calculators. If you remember, I linked into something, either the calendar, but something that you've seen before, that list of calculators that you can use. All right, so let's go ahead and get started. Here is my suggestion with these problems is if you haven't worked them out yet, pause the video, read the problem, attempt it on your own, and then watch how I do it, and then self-diagnose where your issues are. If you simply take notes from these videos, you're never going to learn how to do this. The only thing you're going to learn is that I know how to do the math, not you. So this is very much putting the learning on you. Part of this class, I'm hoping that you learn how to self-diagnose issues so that if and when you have to go into office hours of, let's say, your college professor, you have very targeted questions. Just shrugging your shoulders and saying, I don't get it, doesn't help anyone. For you to specifically be able to say, I can identify the known and unknown, but I'm having issues figuring out what the conversion factors are, that is a very targeted question that will get you a very specific and targeted answer. All right, so the other thing I'm going to do is when I read through these is just do a little bit of reading comprehension. You are under no obligation to do the steps that I say that are optional. I'm simply showing you all the steps, so if you're one of those people who is a little flummoxed, you just don't get what's going on, there are some additional steps that you can follow. Step 1 is simple. Read the problem. So here it says you are a caterer specializing in children's birthday parties. You have 12 birthdays to cater next week. You must bake 2 cakes for each party. Each cake will have 6 candles on it. How many birthday candles do you need for the 12 parties? So congratulations, you did step 1. Step 2 is to figure out what are you trying to solve for, and then what number that you start with dimensional analysis. The what do you solve for most of the time comes after words like how many, how much, which, or the word calculate. So here, how many birthday candles? You are solving for birthday candles. If you are going to do this, I'm going to be consistent and I'm always going to box in what it is that you're solving for. And then you need to pick the number that you start with. And a lot of people make the misconception is you either start with the first number you're given or the last number you're given. You really have to read and see what's going on. You cannot really determine what you start with until you see where the conversion factors are. Now I'm going to do something I haven't really done before, which is I'm going to list them. Now I'm going to take this and set this to the side. You should have this document, and if you don't have it open on your computer, I would suggest that you pause here for a second and go ahead and get that out. So let's go ahead and start with this. You don't have to do this yourself, but it can be very helpful to go ahead and pull those conversion factors out so you can see where to start. So you have 12 birthdays to cater next week. You could say 12 birthdays is equal to 1 week, but as you read the rest of this verbiage, you'll see that there's nothing having to do with time. Odds are this is what you start with, but let's go ahead and find out. So this says you must bake 2 cakes for each party. That word for or per or makes, those are an equal sign. So let's go ahead and write that conversion factor. You know that 2 cakes is equal to 1 party. My handwriting is not fantastic, but yours does not have to be either. So next we have the sentence, each cake will have 6 candles on it. That word each means 1. So 1 cake is equal to 6 candles. So basically a conversion factor is simply an equivalency. This thing is equal to this thing, so you can convert between the two. One elephant has 4 legs. So elephants and legs, you can create a relationship between. So basically the only number you have that's not connected to something is that 12 parties. So let's go ahead and put that in there. So that is the number you start with, 12 parties. Remember, the idea with dimensional analysis is that you are trying to take the unit party and make it birthday candles. And the way that you do that is you use your conversion factors. These things are always connected. In a fraction, one is on the top and one is on the bottom. And then if you remember that units cancel top to bottom, you're in good shape. So here's what I mean. So I'm trying to get rid of parties again and go to candles, and you can see from these conversion factors, there's nothing where you can go from parties to candles. Pro tip, if you don't know how to get to birthday candles, like here it's pretty easy to see that you're going to go from party to cake and cake to candles. But if you can't see that, simply start with a conversion factor that, I'm going to make this a little bit bigger, by the way, so prepare yourself. Anyway, if you don't know where to start, simply start with the conversion factor that has the same unit as what you're starting with. You can see you only have one choice, which is this guy right here. So make your fraction, your conversion factor fraction, and the way that so the question is, does cakes go on the bottom or party goes in the bottom? Well, remember the rule, units cancel top to bottom, so that means that this is going to go down here. So 1 party. Oof, spelling hard. These 2 guys are dating and they're holding hands, so that means that if we pull this here, that's got to get pulled up here. So 2 cakes. Okay, great. I did a math, but the problem is that you are now left with the unit cakes, when in actuality you need birthday parties. So we got to keep going. Well, good news is that there is a conversion factor here. So again, same principles. 1 cake, 6 candles, and there you go. So when you do this, look at candles. Ha-cha. There you go. You did your work. So the problem becomes, how do you do the math? If you just in your mind remove those units, you can see it's just algebra. So you've just got 12 times 2 times 6 divided by 1 times 1. Well, 1 times 1 is 1, so we're not going to worry about it. So you're simply going to put it into your calculator. The reason I'm going to show you how to do this every time is that there are going to be times where you need to use parentheses, and if you don't use parentheses, it will dramatically change your answer. So we put in 12 times 2 times 6, and then I hit equal. And you can see our answer here is 144. So that's your answer. Now, as we're going to see later, there are times you have to consider rounding. That's not a thing here. You got a whole number, you're in good shape. Now, there are different ways to do this. If you choose to do one step at a time and get an answer and then move on, that's fine. But I will tell you that you're under a time crunch on the national exam, so you really want to make sure that you conserve your time as best as possible. So you can also set it up like you would in chemistry, which is like this, or at least how it was when I taught chemistry. 2 cakes, 1 party, 6 candles, 1 cake, Same deal, 144 candles. Now, couple of things to remember. No naked numbers anywhere. Every number that you use in your setup has to have a unit. This has to have a unit. So please make sure that you do that. Also, significant figures are not a thing in environmental science because most of what we're dealing with are exact counts. And so you cannot, exact counts like apples and horses and people are all, and birthday candles are all infinitely significant because it is a precise count. There are other times that we deal with fractional things like liters and kilowatt hours. But again, don't worry about significant figures. The numbers on the national exam have been worked so that you don't have to worry about like the repeating 6 or anything like that. So don't worry about it. You will be fine. All right, so there's a, and also as tempting as it is to box it, and it's a habit that I have, don't, because it allows the reader to go ahead and find the correct answer on the exam. Okay, so there's number 1. So I'm just going to fold this piece of paper so that we can move on to number 2. So pardon my folding as this is taking time. So here we go. So number 2 on that same sheet is right here. Please also notice the reason I'm starring these ones is these are the ones that are going to be typical of what you're going to see on the quiz that we're reviewing for. So there are some that I'm leaving out, and I'll point out which ones. So a manager for a factory farm is ordering corn. Each animal eats 2.3 kilograms of corn per day. Considering all the inputs associated with growing corn in an industrialized manner, fertilizers, pesticides, machinery, etc., it takes 2 liters of oil to produce 10 grams of corn. How much oil is used to grow the corn for a 1-week supply of corn for the 3,000 animals the manager must feed? All right, so we read the problem. Congratulations. Number 2, figure out what you're solving for. And it's right here, how much oil. So you know that you're solving, I guess I shouldn't have boxed that whole thing in. You know you're solving for the oil. It's this guy right here. All right. So then the question becomes what you start with. Well, if you don't know, what I suggest that you do is to go ahead and pull stuff out. So there's actually an extra consideration in here, but we're going to get to that in a second. So the conversion factors that you have are as follows. So let me just make this number 2. Make sure that you can see that, which you cannot. So I'll move that down. All right, let me go ahead and make this smaller again just so we can see what's going on. All right, so you have 1 animal is equal to 2.3 kilograms of corn, 2.3 kilograms of corn. It's really important when you have a measurement to also say what it is, because there are going to be times when you're going to be dealing with kilograms of this thing, but then also kilograms of this thing. So you want to kind of keep that consistent. And then you have 2 liters of oil from 10 grams of corn. Okay. Couple of considerations to make. The first one is that the only number in this whole thing that doesn't have anything equal to it is 3,000 animals. So I know I'm going to start with 3,000 animals. All right, so there we go. A couple of things. The first thing is that all of this is for 1 day. And you're like, great, Morris, who cares? Here's why. When you look, you can see that it wants the information for 1 week. So here's my suggestion. You can put the days and whatnot in there, but sometimes it's easy to go ahead and just start with the smaller unit and then figure out how that multiplies across the time or whatever it is that you're doing moving forward. Okay, the second thing to notice is if you're kind of mapping this out in your head and you're like, okay, I'm going to go from animals to kilograms, that's a unit of mass, and then I can go from grams to liters. The problem is you cannot go directly from kilograms to grams. You also have to do a conversion. So this is a conversion factor you will never be given that has to come from your brain, and that is the conversion from kilo to the base unit. If you remember your King Henry died by drinking chocolate milk that you need to memorize, you would know that 1 kilogram is equal to 1,000 grams. This is the same across all metric units. So 1 kilometer is equal to 1,000 meters. 1 kiloliter is equal to 1,000 liters. There are 2 others that I expect for you to memorize. One has to do with centi and one has to do with milli. So you're not going to need it for this problem, but just to give you an example, 1 gram is equal to 100 centigrams, and 1 gram is also equal to 1,000 milligrams, right? And you can also see how you could go from milligrams to kilograms just by using a couple of conversion factors. So you need to make sure that you memorize kilo to base unit to centi, and base unit to milli. Those are in your brain. So always, my suggestion is, as you're doing these problems, that you're always checking the units and that you're always going back into the problem to make sure you're answering the correct question. All right, so we have 3,000 animals. So again, if you don't know where to get started, which of these conversion factors, where's the only places that they say animal? Right here. So you have 1 animal and 2.3 kilograms of corn. If you didn't notice, I was really tempted to write animal up here, but I knew that was wrong because units cancel top to bottom. Okay, now we're left with kilograms of corn. Well, here's corn here, but it's in grams, so I need to convert this. So I have 1 kilogram and 1,000 grams. And now I can go ahead and do this. 10 grams of corn, 2 liters of oil. So you may also want to make a note to yourself and also to the readers who will be grading this, that this is for 1 day. Okay, when you do stuff like that, it's a nice remembrance for yourself, but it's also to kind of let the readers know that you recognize that this is all just for 1 day. Okay, so when you work this out, you're going to see that it's 3,000. Here's how you do this. So let me go ahead and turn this on again. Okay, clear that out. 3,000 times 2.3 times 1,000 times 2. It is at this point that you want to hit the equal sign. So equals. Now you can see divided by 1 times 1 times 10. Really the only number you've got to worry about is this boy right here. If you had more than 1, you'd need to use parentheses, and we will see one of those in the practice. So now you go divided by 10, and you have this number right here. We will eventually, in the course of the year, I will teach you how to use scientific notation. It's not necessary, but it will make your life a lot easier. So here you've got 138,000. And remember, that's not a good answer because you have no units. Liters of oil per day. It's kind of nice to show that you understand that this is per day. If you don't remember that word per, you can write in 1 day. That's fine. All right, so next problem is, okay, not the next problem. So you go back and check and you're like, I did a math, but here's the problem. It's 1 week. So what you have to do is take this boy and go 138,000 liters of oil, and that is per day times 7 days, because that's a week, is equal to, so times 7, and you get this answer, 966,000 liters of oil. Hooray, we did it. All right, so let's go ahead and move on to the next problem. So on these problems, number 3 is one that we're going to skip for right now because we haven't discussed how to do kilowatt stuff. And then number 4 talks about efficiency, also something we haven't done yet. And we will get to that probably in energy. Just to let you know, because I know this video has gone on for a little bit, I think I'm going to self-contain these particular slides to one video. I'm going to do a separate video for the extra practice problems dimensional analysis, and then I'm going to do a third video for the scientific method problems, the ones that look like this. Okay, so we're just going to make those all separate. So the next problem that we have is this one. So number 5 says, after determining your ecological footprint, you discover that your energy consumption is very high. Your family uses BTUs, British thermal unit, of electrical power per month. And how much was your electric bill? You have 1 BTU is this, 1 kilowatt hour is this. Do you need to know what BTUs and kilowatt hours are? No, it could sake or sprinkle flump. It wouldn't really matter. So just know that they're units, recognize that they're different, and off to the races you go. So, read the problem, congratulations. Secondly, pull out the conversion factors. We don't even have to do that. They gave them to us right here. So the only number that's by itself is this gigantic number. So I'm going to go ahead and write that down. Do you have to write out the conversion factors? No, you do not. That is just simply, especially if you don't know where to start, sometimes it helps, like you're building a puzzle, to kind of take all the edge pieces and put them over there, and take all the blue pieces and put them over there, so you can solve the problem. So you don't have to do that. It's all lined up. So let's go ahead and write this. So you have 6, 8, 9, 6, 5, 5, 1 BTU. Do you need to put the commas? No, you do not. So at this point, I'm hoping that you can kind of see the pathway that you would need to follow. So you want to go from BTUs to what you need to do is this, how much. Okay, this is where you need to understand that how much, that's money. I did 1 too many. There we go, money. Okay, so you want to solve for this boy. So you want to go from here to here. And this is even nice because it kind of lined it up for you. This conversion factor will take you from BTUs to kilowatt hours, and this one will go from kilowatt hours to money. And where it says costs, just know that that is also an equal sign. All right, so let's just do the thing. So you've got 1 BTU is 0.00029 kilowatt hours. Do you need this first 0? No, you don't. That's just a style thing. And then you have 1 kilowatt hour costs 16 cents. All right. And really all you have to do is multiply across the top. So you've got 689,651 times 0.00029 times 16.16, and you have this number 319.999. It will tell you on the national exam. They will not do this to you. Remember, you're dealing with money, so that means that you want 2 decimal places, and because this is 0.999, what they would actually do with a bill is they would actually round this up. There are times when you have to kind of decide if you round up or round down. This is one of those times when you're going to round up. So your answer is $320. Bang, not hard. Okay, so 6 is another one of those. It's a little bit more complex. We'll save that for another time. So let's go ahead and talk about 7. I will tell you for 7 that there is a conversion factor that should be on here that is not, that you do not have to memorize. I would have to give this to you. So here we go. Dwight bought 10 acres of land and built a house on 2 acres. Dwight wanted to plant beets on the remaining 8 acres. If it takes 1/8 or 0.125 of a hectare to grow 150 beets, how many beets can he grow on the 8 acres? So a couple of things about this. The first one is that, sorry, I'm just checking my notes to make sure that I told you everything you needed to know. First one is a hectare. There are other ways of saying it, I'm sure that's just how I say it, is the way the rest of the planet measures land area. We here in the States do it in acres, and ha is the shortened of hectare. And then also notice you have extraneous information. That's great, he bought 10 acres of land and built his house on 2 acres. We don't care. We're only interested in the land that he's growing beets on. So again, if you're having issues deciding what to start with, why not just pull out the conversion factors and see what's left. So if it takes 1/8 of a hectare to grow 150 beets, so you have 0.125 hectares to grow 150 beets, and then you also have 1 hectare is equal to 2.47 acres. you can see that the only number that, and we don't care about this part. That's nice, Dwight. We don't care. The only number you're left with is 8 acres. So you have 8.0 acres. Multiply. The only thing that's up here that has acres is this bad boy. So 2.47 acres. And then 1 hectare. Oh. And then you have this right here, 0.125 hectares. It's 150 beets. Again, I know I set it up right because I'm left with the unit of the thing I am looking for. All right, this is an issue of where you have to use parentheses. So what I'm about to write, you do not have to write on a test or a quiz or whatever. I'm just showing you how to put it in your calculator. So you have all the stuff on the top. So you'd go 8 times 150. You hit equals, and then you would go divided by parentheses 2.47 times 0.125, close parentheses, equals. Here's why you need to do that. If you simply put in 8 times 150 equals divided by 2.47 times 0.125, and you did not use parentheses and then you hit equals, here's what your calculator would do. You would take 8 times 150, multiply that together, divide that total by 2.47, and then whatever this was, it would then multiply it by 0.125. In other words, it would take the 0.125 and put it in the numerator. You have got to use parentheses to keep those denominator numbers from floating away, basically. All right, so how does that look when you put it in your calculator? So you've got, I'm just going to use this as my guide, 8 times 150. I hit the equal sign, equals, okay, and then divided by, here's my parentheses, 2.47 times 0.125, close that parentheses, and then hit equal, and you can see that we get this answer right here. So I'm going to call that 3886.6 beets. Here is where you also have to use intelligent rounding. You cannot have a fractional beet. A beet is a thing, right? Even if it's like a little stunted beet, it's still a beet. So this is, what is the question asking you? How many beets can you grow? This is the maximum number of beets that you can grow. So if you were to follow normal rounding rules and say 3887, that is one too many beets. You cannot have more than 3886.6 beets there. So that means that you must round down, which is the intelligent rounding, 3886 beets. And there you go. All right, we've got one more on this video, and then I will stop it, and then I will film another one for the other stuff. All right, so one more. Let me just go ahead and get a fresh piece of paper. So here we go. And then here's our last one. Okay. Michael wants to throw a pizza party, so his 15, it really should say employees here. They're not co-workers if you're the boss. His 15 employees will think he's the best boss ever. Each pizza will cost $19.50 and has 12 slices. He wants each person to be able to have at least 3 slices. He has $90 to spend after returning a George Foreman grill. Can he afford enough pizza? So this is basically asking for you to compare things. So you're going to figure out how much the pizza costs. You're going to compare it to the money he has, and you're going to say, yes, he can do it, or no, he cannot. So what you're going to do is you're going to ignore this number. That's the comparison for later. What you need to do now is to figure out what you're solving for, and then what number you start with. So this question here is, can he afford enough pizza? This word afford is how much money it is. So you're solving for monies, okay? You're solving for that dollar sign. All right, then the question is, well, what do I start with? Well, let's go ahead and pull out the conversion factors. So 15 is not attached to anything. That's probably what I'm going to start with, but let's see. So each pizza will cost $19.50. So I have, let's see, this is 8. I have that word each, remember, means 1. So 1 pizza is equal to $19.50. And then you have 1 pizza is 12 slices. And then he also tells you he wants each person to have 3 slices. So 1 person, 3 slices. All right, so when you go through all of that, you might be tempted to start with the $90, but again, remember you are comparing it to this, so you're setting that to the side. The only number that you have left is this one right here, which is 15 employees, or 15 people, really. Okay, so there's a question I think that you could ask, which is, will Michael be having the pizza or not? I will say on the national exam, they will make that very clear. So I'm just going to solve for the 15 people, and we'll go ahead and go from there. So 15 people, and then we're just going to go ahead and use our conversion factors. We've got one person gets 3 slices. We've got 12 slices. Okay, in every pizza. And then we have that a pizza is $19.50. And you can see here how valuable dimensional analysis is, because it lets you know if you're going to be multiplying by a number or dividing by a number. So people, slices, pizza, and you're left with dollars. So now it's just the math. So it's going to be 15 times 3 times 1 times $19.50 divided by 12. And let's go ahead and do that. 15 times 3 times 19.50. Hit the equal sign and then divide it by 12. And remember, with money, you round up or round down so that you have 2 decimal places. So that means that this is going to be $73.13. So since $73.13 is less than the $90 that he has, Michael can afford the pizza party. Please note that this question did require for you to make some sort of statement. So when you're asked a question with comparison, can you do this, can you not do that, whatever, you need to make some sort of statement. So you can see the statement there is, part of it is this. If you don't remember the equal sign or the less sign, look, things happen when you're under pressure on the national exam. You could say the cost of the pizza is less than the amount of money that Michael has, therefore he can afford the pizza party. Whatever, it's all the same thing. All right, so I've just run through the 5 out of the 8 problems on the dimensional analysis stations activity that you can use for practice. I'm going to stop the video here, and then I'm going to go ahead and transition to this dimensional analysis, and then I'll make a separate video for this. So